Hey everyone, Chang here and welcome to my channel. Today we're going to cover a topic that for one way or another we will have seen in school, but we never really focus on the significance of it. It's one of those like, please memorize this, produce it on an exam, and then you're done. Well, that's not the case. Now, as you study more and more math, this plays a crucial details in how problems are written, interpreted, so on and so forth. And just by missing this detail, it can cause drastic error. You could be approaching a problem completely the wrong way. So hopefully we'll be able to change that. That's right, today we're going to cover number groups or number sets, depending on how you want to interpret it. It goes by various names. Now, by the end of this video, you're going to know things like counting number, natural numbers, integers, what the difference is between them. And I'll also try to address some of the confusion because certain textbooks use these vocabulary terms a little differently. So hopefully we can clarify that. Well, let's just start off with why we need number groups or number sets in the first place. Now, without going into extensive history, I believe that the reason these number groups or number sets came up in the first place is because as we started developing our understanding of numbers and of math in general, we just needed a way to sort of describe certain sets of group that has like a shared quality. So we're just going to go over each and every one of them, figure out what the difference is, what the similarities are, so that when we use these vocabulary, we will know exactly what we are talking about. The first group is sort of intuitive, in a sense that we already know it's there, but we just needed a name for it. So we gave it the easiest name possible. It's called counting numbers. Now you guys can imagine what counting numbers are. They're basically numbers that help you keep track of things when you're counting. Now when you first started to learn to count, it's basically 1, 2, 3, 4, and then so on and so forth forever, right? That's what counting numbers are. Now here's several things I want you to notice about counting numbers. First and foremost, they're all whole numbers. So there's no parts of numbers. 0.5 is not a counting number. 1/3 is not a counting number. Other than that, any whole number is a counting number. 37, yes, that's a counting number. 45, yes, that's a counting number. 3,283, yes, that's a counting number. Now, notice this. Remember, it's all whole number, but we don't have 0. 0 is not included in the counting number. And that's kind of odd, but there is some argument that 0 actually came after the regular number system. So 1, 2, 3, 4, and then on and on. We only added 0 afterwards. Hence, the original counting number set doesn't have 0. Well, the next logical steps is just to include 0. So what we're going to do is we're going to create a group called the natural numbers. Now this is very similar to the counting numbers, except for now it's including 0. So 0 on all the positive whole numbers. Well, here's the thing. Even though it's called natural numbers, well, this is the symbol, it uses this n. There are some other names that you would see in other textbooks. One of them is just called whole numbers, which I guess makes sense because, I mean, 0 included with all the rest of the whole numbers. Now, another one is actually called the non-negative numbers. This is just basically all the numbers excluding all the negative side, hence the non-negative numbers. So these are some of the names you will see to describe this group, but it's basically the same thing. It's all 0 and all the positive whole numbers. Now, this next group of numbers, and a lot of them after that, is built because of our understanding of numbers, and our understanding of math is getting more and more complicated. Now, what do I mean by that? Well, first and foremost, we have the counting numbers and the natural numbers. Well, when we're adding numbers, when we're counting basically, everything is fine. Everything is great, right? 11 plus 4 is 15. That's fine. That's still the counting numbers. That's still natural numbers. When we started subtracting numbers, that's when it gets a little iffy. When you're subtracting large number and a small number, that's still fine, right? 6 minus 4 is 2, still counting number, still whole numbers. Now, if we started subtracting small numbers with large number, that's where the error comes in. If you had 3 and you subtract 5, unless we have another set of numbers, we really can't do much. So we make another set of numbers. They're called negative numbers. So we have now 0, all the positive whole numbers, and now all the negative whole numbers as well. So guess what? We need a name for this entire larger group. That's called integers. Now, integers is represented by the symbol z, and the reason for that is because the z is the beginning letter of the word the Greeks used to represent integers. So now we have this new one. Integers is all the 0, positive whole numbers, and negative whole numbers. Now, before I start throwing more number sets at you, I want you guys to notice something. There's going to be numbers that actually belongs in multiple groups, but there's also going to be numbers that belong in one group and not the other. Now, what do I mean by that? Well, for example, let's look at the number 4. Number 4 is in a counting group, yes. It is in the natural number group, and it's an integer. But for example, 0, it's not in the counting group, but it is in the integers and it's in the natural numbers. Now, a negative number, let's just say -7. -7 is not counting, it is not natural, but it's in integers. So you got to be very careful. Each and every one of these groups have specific criteria, and you can tell if a number belongs to a certain group or not. Well, let's start going through more groups. At this point, we have integers. We're pretty satisfied. We have our negative whole numbers, we have our 0, and we have our positive whole numbers. We can add them, we can subtract them, we can even multiply. When we multiply whole numbers, there's always going to be whole numbers. Now, the trouble is when we actually start dividing numbers. When we start dividing numbers, we realize that when you get one whole number and you divide it by another whole number, the result is not always a whole number. Well, a simple example is this. Let's just get 1 and we divide it by 2. Guess what? The answer is 0.5 or just 1/2. That's not a whole number. So there it is. Now we need another group to encompass this kind of set of numbers. And we call them rational numbers. It's represented by Q right here. Yes, it's a little weird that it's Q, but Q stands for quotient, which is division. And in this case, this number set came from us dividing numbers. Now, we need a set of rules because then when we're talking about parts of number, there's two ones that we're comfortable with. There's fractions and there's decimals. And we don't want two different sets of fractions and decimal. So for rational numbers, we actually make this a requirement. For a number to be a rational number, it has to be a number that can be written as a fraction. So what do I mean by that? For example, 0.25 or a quarter, right? 0.25, technically a decimal, it's not a fraction. So it shouldn't be a rational number, right? But that's not really the case because 0.25 can be written as 1/4. And in that case, it's a fraction. So it belongs in the rational number group. Now, you guys can guess that there's no heck way we're going to be satisfied with that. Even though we have a fairly complicated math numbering system, or groups I guess you could say, rational numbers, all numbers that can be written as a fraction, we start to realize as we study more and more, there are certain numbers that cannot be written as a fraction. So for example, pi, square root 2, square root 3, e, none of those can be written as a fraction. So we need another group. Well, guess what? They're not rational numbers because they can't be written as a fraction, so we call it irrational numbers. Now, in order to encompass both the rational and irrational number, we created what is called real number. So it's represented by R, as you can guess, for real numbers, and that's encompassing all the numbers that we are working with so far. So those are all the common group of numbers and the number sets. But here's the thing, there's many more. There's like stuff like imaginary numbers, the opposite of real numbers. That's basically square root or root to the 4th power of negative numbers, so on and so forth. We're not going to focus on that. Now, we have more specific ones like even numbers, all numbers that can be divided by 2, and odd numbers, all numbers that cannot be divided by 2. We also have prime numbers where when you try to factor it, it's only the number and itself and nothing else. And of course, there's the composite number, which is the opposite of that, which means that you could break down the number into smaller factors, and on and on. So at this moment, actually, is quite overwhelming. But here's the thing, the point is not to memorize every single possible number groups or number sets out there. That's not a productive use of your time at all. Know the common ones, but more importantly, know the specific detail. What would make one number belong in one group over the other? And that will help you tremendously. Let's go over some examples to see that just subtle differences can drastically change a problem. For example, let's look at something as simple as this. Let's just say we have two numbers that belong from the counting number groups. When you multiply those two numbers, the answer must be positive. Yes or no? Well, yes, the answer is yes, right? The reason we know that is because guess what? For numbers to be in the counting number groups, they must be positive they must be whole numbers. So basically, if the two numbers are from the counting group numbers, they're two positive whole numbers. Now, from our experience, when we multiply two positive whole numbers, the end result is still going to be a positive whole number. So, of course, the answer is yes. Now, if we change the wording just a little bit, for example, instead of saying that those two numbers are from the counting number groups, let's just say the two numbers are from the natural number groups. Now, all of a sudden, the answer is actually going to be no. Why is that? Well, let's just say, for example, if one of the numbers is actually 0, any number times 0 is just 0. And we know that 0 is not positive or negative. So no, the answer will not always be positive. Whew. Now, that is very different from our regular videos. This is a lot more conceptual based, just understanding definitions, understanding concepts, rather than actually doing the math. But there are certain problems that will help you hone your skills. So let's begin.
1.
Just a keynote, I will have the answers in the description for those of you guys who are curious and want to check your answers.
3.
Thank you for sticking with me until the end of this video. Let's summarize basically what we went over. Counting numbers are all the numbers 1, 2, 3, so on and so forth, all the positive whole numbers. Natural numbers now include 0 and all the positive whole numbers. We have integers that include the negative whole numbers, 0 and the positive whole numbers, and from there we develop the rational numbers. That's all numbers that can be written as a fraction. Now, with that, we also realized that not all numbers can be written as a fraction, so we developed the real number to encompass the irrational numbers as well. Now, on the side note, we also have the more specific ones. We have the imaginary numbers, we have the prime numbers, the composite numbers, we have the even and odds. Now, the point is not to memorize every single possible group out there. What is more beneficial is to know the key difference separating one group from the other. Just by knowing this key difference, you'll be able to focus and pay attention to it when you encounter problems that specify specific number groups. And remember, a lot of them are just basically subgroups, smaller groups inside a larger group. Remember, the largest group is real numbers. Inside we have two possibilities. We have the irrational and the rational numbers. And inside the rational numbers, we have the integers. Inside the integers, we have the natural numbers, and inside the natural numbers, we have the counting numbers. And from there, we realized that if the number's in the smaller subgroup, then it's guaranteed automatically in the larger group as well. But don't forget, it doesn't work the other way around. Just because it's in the real number doesn't guarantee that, for example, it's gonna be in the natural numbers or the integers. Now lastly, please like, comment, and subscribe so all of us can actually pay attention to key details inside a problem. Just a change of a number set can drastically change the potential answer of a problem. So with this understanding, you can avoid mistakes like